This is a question about reaction rates and deciding what is a faster reaction. Okay, so before we dive into this, we need to look at the alpha carbon here and count carbons. This is a tertiary alkyl halide, which means the reaction is going to proceed by SN1. And it looks like we have a water here, which is the reaction solvent, and it's the reactant as well. So that's polar product, right? That's the solvent or the reactant. And then we have the product, okay? Now, the thing to really remember here for this chemical reaction is that, let's think about part A here, is that for SN1 reactions, okay, the rate is going to depend on the concentration of the starting tert-butyl iodide. Now, it's not going to depend on the water at all, okay? So if you increase the concentration of water, it's not in the rate equation, it's going to be the same, okay? Same exact reaction rate, okay? If you decrease the concentration of halide, that's this substance here, okay, the rate's going to be lower because the rate is dependent on the concentration of the starting alkyl halide. So the halide, that is going to go down, okay? So that's going to decrease. What if we change the leaving group to a bromine? So remember, for your leaving group abilities, iodide is a better leaving group than bromide, is a better leaving group than chloride, is a better leaving group than fluoride. So bromide is a worse leaving group, and so this means that it's going to be a slower reaction, okay? So it's going to decrease the rate, okay? And what if we start with 2-iodopropane? So let's draw that molecule out and see what it looks like. Here's propane, okay, 3 carbons, and then we have an iodine at carbon 2, all right? This structure here, if we look at it carefully, has an alpha carbon, and it's connected to 2 carbons, so this is a secondary alkyl halide, okay? Now, up in the original problem, we had a tertiary alkyl halide, and here we're switching to a secondary alkyl halide. Now, recall, for an SN1 reaction, tertiary alkyl halides are going to react faster than secondary alkyl halides. So this makes the reaction worse. It's going to be slower. The rate is going to decrease. Okay? I hope you are summarizing all of these effects on a separate card or something, but this in a nutshell is how you answer this problem. Thanks for watching, and please do consider subscribing.